Physics Part 121. Eventually the temperature is increased to the boiling point. Here, if atoms are to escape into the gaseous phase, the interatomic forces in the liquid must be overcome. The energy input here is the latent heat of vaporization. This goes to moving the molecules far enough apart for the interatomic forces, and hence the associated potential energy to be negligible. Remember that one of the assumptions of the kinetic theory is that for an ideal gas there are no interatomic forces. As we have seen, the latent heat of vaporization is much greater than the latent heat of fusion. Note that the boiling occurs only at a particular temperature for a given atmospheric pressure. We have associated boiling with a definite input of energy, the latent heat. However, molecules are lost from the surface of a liquid at any temperature by the process of evaporation. The molecules in a liquid do not all move with the same speed, as we know from our work on the kinetic theory. A molecule with a high enough speed may escape from the attractive forces of the molecules in the surface region of the liquid and leave the liquid entirely. This process can take at any temperature. However, the higher the liquid temperature, the greater the number of very fast molecules and the greater the rate of loss of molecules from the surface. This fits with the everyday observation that the evaporation rate increases with an increase in the temperature of the surroundings. The loss of the fastest molecules means the average speed of those remaining falls, with a corresponding fall in average kinetic energy and hence in temperature. This means that the evaporation tends to cool the remaining liquid. This too is an everyday observation. So although both represent a change of state from liquid to vapor, we distinguish between evaporation and boiling by the fact that evaporation can take place at any temperature, whereas boiling takes place at a fixed temperature for a given pressure of the surroundings. Furthermore, evaporation takes place at the surface of the liquid, whereas boiling occurs in the body of the liquid. In describing this simple model, the words atoms and molecules are often used interchangeably. More precisely, we ought to consider whether we are describing an element for which the word atom is usually appropriate, though some elements such as oxygen O2 exist as molecules, or a simple molecule compound for which the molecule should be used. For example, in talking about the boiling of water, we are concerned with the forces between water molecules and the loss of the water molecules from the surface. The structure of the solids, liquids, and gases. Let us now try to get an idea of the spacing of the atoms or molecules in your simple model of matter. We can estimate this quantity for a solid by using known values of its density and the mass containing one's mole or molar mass. You will find that an answer of the order of 10 raised to minus 10 m will come up each time. The quantity will come up catch time in calculations such as an example, and we can take this as being the order of the magnitude of spacing of atoms in a solid. We can do similar calculations for liquids and gases, although of course the assumptions of about assumptions about the cubic arrangement of atoms now does not make sense.